Lovely. Hey, welcome back, everyone, after lunch. Hope everyone had a good feed and ready to do some more learning. So when I get asked to do the chairing for some of these sessions, you get asked which ones you want to kind of pick in terms of tracks. And I saw Lloyd's name. I'm like, yeah, absolutely, I have to be part of this one. So I was probably going to be sitting in the audience anyway. So we're quite fortunate to have people like Lloyd and some of the other presenters here today, because genuinely represent some of the leading minds in what they do. And things like red teaming is quite near and dear to my heart, because I spend a lot of my working life doing it. But anyway, so in this talk, we're going to be delving into the changing landscape of red teaming by examining some of the typical engagement life cycles, recon, initial access, and so on and so forth. And at each stage, Lloyd will be kind of highlighting some of the attacks and how they evolved over time. So can we give a warm AUSCERT2025 welcome to Lloyd as he makes up his way on the stage.
Thanks everyone for coming to my talk on evolution of red teaming. Quick agenda. We're going to look at red teaming in the form of 2 case studies. We'll go through those case studies and sort of how they differ and how things have changed over the years. So I'm Lloyd. I'm the Managing Director and a co-founder of Tanto Security, an offensive security consulting company. I've been doing red teaming for roughly 10 years now. I know to some of you that's probably not very long. But I think there's been a lot of change over this time, and I think it's interesting to have a look at. So this is Marcio. Myself and Marcio, we've worked together for a long time. I put this slide in here, 1, because I wanted to put it on a big screen, and 2, because the idea for this talk sort of came about from conversations we've had over the years. So initially, me and Marcio, we worked together at the internal red team at Telstra. And then he got a bit too cool for us, and he left and went to the internal red team at Canva. And we continued talking. And I noticed that the challenges he was facing at Canva and the ones we were facing at Telstra were very different. And the tools and techniques we had to use to overcome these challenges were very different as well. So about 3 years ago, we, along with another friend of ours, created Tanto Security, and we've been doing red teaming consulting since then for various other organizations. So what is red teaming? I think it's important to get everyone on the same level, get an idea of what we're talking about. My natural instinct was to look at the Corey framework. Are people familiar with the Corey framework? Hands up. Yeah. I have mixed feelings about it. This was the definition that they offered. I don't think it's a very good one. When you have to use the term in the explanation, it's probably not great. So the next place I went to was NIST, and this is their definition. It's pretty wordy. I'm not going to read it out. There's a lot in there. So I have created my own, because why not? But I've broken it down into a few different points. The first being it's a simulated adversarial attempt to breach an organization. The second, and I think this comes from that, is it should begin external from the organization, in most cases from the internet. I've seen some argue for like an assumed breach model, and I think this can form part of a red team, but shouldn't really be the start of your red team, right? You need to have some clearly defined business objectives, the key here being business objectives. Some people might say get domain administrator. This doesn't mean a lot to a lot of business people, and something that's probably more relevant is get credit card information from some system or XYZ system, get intellectual property, those kind of things, right? And it should be informed by the threats that an organization faces. I don't mean here you have to go out and identify what APTs are targeting your sector and mimic them exactly, but I do think you need to come up with some realistic scenarios for your red team. And the example I like to use is often we get people come and ask, oh, can you do a physical red team for us? And I like to ask them, well, how often does someone try break into your building or into your offices versus how often does someone click on a link in an email that they shouldn't, right? So yeah, it's important to kind of have those realistic scenarios. And then finally, and maybe most importantly, you want to test both the technical defenses and the playbooks of defenders, and make sure that those procedures and processes are in place and that they're followed and everyone knows what they should be doing when a breach is detected or occurring. Okay, so I want to introduce two case studies. They're fictional case studies. The first one is Dunder Mifflin. So Dunder Mifflin is a paper and office supply company. They have a sales portal where you can go and buy paper online. They have multiple offices and warehouses all across the place, and they're going to represent our on-premise Windows domain, so kind of that older legacy style company. The second case study we're going to look at is Pied Piper. Pied Piper are a Silicon Valley startup. They, like all good Silicon Valley startups, have pivoted to a number of products over the years. The current iteration is a video chat application. They offer a flexible work environment where users can work from a cafe, they can work from their house, they can work from a share space, that kind of thing. They represent our cloud-first zero trust environment. They utilize a lot of software as a service or SaaS services to provide a lot of the business functionality that they don't want to do themselves. And I should say the crown jewels in what we're going to be going after in this red team is customer information from their production environment. And likewise, in the Dunder Mifflin example, we'll again be going after customer information from their production environment of their sales portal. So these two organizations I like to think as representing two ends of a spectrum. And most companies we see are somewhere in the middle, right? They have incorporated both of these ideas, and they're in some state of change from that sort of Windows domain towards using more SaaS services. So my hope is that you will see sort of aspects of both of these case studies in your own organizations, and you'll be able to take something away from both of them. So red team activities. Some people call them like phases or stages. I prefer to use activities because there's no like implied order necessarily there, and it's much more of a feedback loop than I think phases or stages implies. So just quickly running through them, you've got reconnaissance, initial access, privilege escalation, lateral movement, exfiltration, and then you either ask for a ransom or you do some reporting depending on whether it's a sanctioned engagement or not. So we've decided that we have an objective, we have a scenario for our red team. We want to do some phishing in order to get a beachhead and an initial access point into these organizations. But before that, we need to do some reconnaissance and find out as much as we can about these companies, find some potential targets, that kind of thing. So one of the first things I like to do is look at LinkedIn. Look at a business on LinkedIn. It's great for getting employee names, their positions, their locations, where they are in the world, which is really important when we want to start doing some phishing, because it makes a lot more sense to send a phishing email on a Friday afternoon when people are tired and want to get to their weekend than it does on a Monday morning when everyone's fresh and ready to go, right? And we can combine this information with breach data and stealer logs. In particular, stealer logs is something that we really like to use at Tanto. The reason being that breach data itself tends to be more public. These are very public exploits that are well known about. So an organization is much more likely to have done a lot of cleanup and is aware of these compromises, as opposed to stealer logs, which comes from essentially people installing malicious browser extensions in their browsers. So it's individuals that have been compromised. So the organization is less likely to know that these individuals have been compromised. So that means the credentials are more likely to be correct. It also means that they also store the URL of where these users have tried to log in. So with those URLs, you can identify potentially what SaaS services an organization is using or what internal URLs that might exist within an organization. And finally, we get an idea of what the email address format is like for these organizations. So is it first name, last name @company.com? Is it first letter, last name.com @company.com? That kind of thing. So we can combine this with the information we got from LinkedIn to create a pretty substantial list. And then finally, we want to do some asset and service identification. Things like looking at DNS records, IP addressing, tech stack, find out as much as we can about the organization. Okay, so we're going to apply some of that to what we know of these two case studies. This slide represents the internet, and we're going to build up a mental model of the logical architecture of each organization as we go through. So we know that Dunder Mifflin is a Windows domain. So typically, these operate in a private LAN that's firewalled off from the internet. So we can assume that they're going to be firewalled from the internet on a private LAN. Within this domain, they're going to have things like domain controllers, users with workstations, servers, and the production server and database that we're interested in. But for now, we don't really know what's there, right? By looking at the Stealer logs and LinkedIn information, we've been able to identify two users. So Dwight Schrute, who's in the sales department, and Pam Beasley, who's an office administrator. And then we've identified that the email address for these users is the first letter of the first name dot last name at dunder.com. We can't really find out too much more about this organization until we get a position within the network. So this is sort of what we have to work with at the moment. In contrast to this, if we have a look at Pied Piper, again, this slide will represent, we're going to build up a mental model of their logical architecture as we go. But we know that they don't have this Windows domain, so they don't really operate in a private LAN per se. Their users log in from all over the place. Using Stealer logs and again LinkedIn information, we've been able to identify 3 different users. Richard, who's the CEO, Jared, who's a BDM, and Dinesh, who's a developer. But we can find out a lot more about Pied Piper as well. So by looking at their website, we can identify that they're using AWS, as the IP address is an Amazon IP address. The name servers they're using are Amazon name servers, and they might be using AWS Gateway or something like that for their API. We can also, looking at DNS records, and specifically the MX records, if we see that they're using Google servers, we can suspect that they're potentially using Google for email. And then we can confirm this by sending an email to idon'texist@piedpiper.com and looking at the headers in the bounce. The next thing is we go and we take one of these users and we try and log into Google. And we get redirected to Okta. So at this point, we can assume that they're using Okta as their identity provider. And this is important because in this organization structure, a lot of the users are managed via the identity provider and does all of the authentication, and then they use single sign-on to access all of the different services that they rely on. Finally, we do some Google searching, and we find a GitHub organization called Pied Piper. Could be them, could not, but we'll add it in for now. And by doing some subdomain enumeration of some well-known SaaS services like Slack, we identified piedpiper.slack.com. So we are making the assumption that they're using Slack for communication here. All right, so as you can see already, our two, logical architectures are diverging quite a bit. And the ways in which we want to achieve initial access in both of these organizations is different. So if we go back to looking at Dunder Mifflin, the big problem we have here is because they operate on that private LAN, and all of the servers and services that the users are going to be using exist within that private LAN, we don't really have a lot of access. They're firewalled from connections directly in, but the users, in order to do their work, they need access to the internet. So they allow outbound connections. So what we want to do is, I've gone too far, essentially spin up a server on the internet, convince one of these users to run our own payload, and then that will beacon back out to our server on the internet. And in that method, we have access to the internal environment. So some considerations with our payload. EDR and application allow listing are definitely the biggest headaches from my point of view. They are a great protection, and they're definitely difficult to get around. There's also other things like network detection response and network proxies that we need to be aware of, but I don't think they're as much of a concern and provide as much of a challenge. So over the years, there's been, a number of different style of payloads that red teams can use. If we go back sort of pre-2015, I think browser exploits were a viable option. Adobe Flash was hanging around. It had a lot of vulnerabilities that were fairly publicly known. And end days were much more exploitable because patching was not as automated. The memory corruption mitigations that exist in browsers today weren't as widely applied. So unfortunately now it's not the case for me, but good for everyone else, right? So the next kind of class of payloads we can talk about is email attachments. I think most people will be familiar with your Office macros or your malicious Word documents. These worked really well even up to a few years ago. There's some other classes there, HTA files, link files, and your various scripting languages. The problem with these now is that the email filtering has got quite good, and it's quite good at detecting malicious attachments. So the next class of initial access payloads I want to introduce is browser-based installers. And these are a suite of technologies that were produced by companies to help developers distribute their software. And people probably used them before. It's like when you go to a website and you click on a link and it will have a really nice user experience for installing software. Most of these are disabled by default now because they were used for malicious activities. And then finally, we've got trusted executables, or your living off the land binaries, which are typically applications that are already installed on a machine and trusted. And then you provide, say, a configuration file or something along those lines that the application will execute your code with. And then there's also things like TeamViewer and AnyDesk, which are legitimate software that are provided for like help desk style use cases. But if you can convince someone to install it, you get remote access to the machine. And depending on the organization, they may be trusted more or they may be trusted less. Cool, so we've got our initial access payloads. We need to select a target, and this is largely informed by what type of payload we can execute. Because of the difficulty in executing code on someone's machine, we're not too picky with our target, but we go after someone with the greatest likelihood of success. And then we can also only target users for which we have email addresses as well. And then we come up with some kind of pretext. So maybe there's security teams rolling out a trial for some software. Can you install it? Something along those lines. A reason for someone to install something on their machine. So what does this look like? So here's our really cool and handsome red team guy. He spins up a command and control server on the internet. And then we've decided to fish Dwight because we know Dwight is in the sales team. He's probably used to receiving emails from outside the organization, and he's probably used to opening all kinds of weird attachments and stuff. And he's not in a technical role, so he's probably less likely to be wary, right? He executes that. It beacons out to our command and control server. Our red team operator can now log in and start queuing up commands, and his machine will pull those commands down, execute them, and then push the results back up to our command and control server. Cool, so we've got our initial access in Dunder Mifflin. If we switch gears again and have a look at Pied Piper, obviously because all of their services are already on the internet, we already have access to a lot of them already, right? So the relationship we're interested in here is really the one between the user and their identity provider. Because if we can get access to the identity provider as one of these users, then we can log into, say, AWS via single sign-on, or we can log into Google as that user via single sign-on, right? Slack, GitHub, all of the different services for which they have access to, we can get to. So the most obvious way to do this is credential phishing. So back in the day, you'd spin up a website and totally legit, please put your username and password in and you're good to go, right? But then, that was a bit of a disaster. So we came up with multi-factor authentication and all the different forms of it. What's interesting is all of these, except the bottom one, FIDO2, are vulnerable to what's called an adversary in the middle attack. And I'm going to talk about FIDO2 a little bit later. But the ones I've highlighted are by far the ones we see the most in organizations. FIDO2 really hasn't taken off yet, but I think it will soon. So yeah, in order to understand how we're going to attack this, we first need to have a look at single sign-on and how single sign-on works. So on the left, I think, left, yeah. I've got the user's browser. On the right, up the top, we've got the identity provider. So this is the thing that does the authentication, like Okta in our example. And then we've got a service provider down the bottom right, which is the service we want to access, so maybe Slack. The first thing that happens is the user logs into the identity provider. That they do username, password, and their MFA, and they get a session back with the identity provider. On the dashboard in the identity provider, there'll be a bunch of tiles with all the different services they can access. They click on one of these tiles, say Slack, and the identity provider will return a redirect with a token that the service provider will accept. The user's browser then follows the redirect and includes the token to the service provider. The service provider, now this is like protocol specific, but I think the concept remains the same, validates the token with the identity provider. And once that validation is done, a session is created with the service provider for the user, and they can then start using that service. Cool. So with our adversary in the middle attack, the part of this that we're interested in is the initial logon and session with the identity provider. So we're going to introduce our adversary in the middle server. And the first thing we do is we socially engineer our user into logging into our adversary in the middle server. They think it's the identity provider or something like that. We then forward their credentials to the identity provider, and this includes their MFA. The identity provider returns a session to us, and then we can redirect the user back to the legitimate identity provider. We don't really care what happens to them at this point. They think they've put in the wrong password, something like that. From here, as the adversary, we can start clicking on some of the service provider tiles, and we get a redirect with a token. We follow that redirect to the actual service provider, include the token. The service provider validates the token with the identity provider, and we now have a session with the service provider. Okay, so what do we need to do to set this up? We need to obviously set up our adversary in the middle phishing server. We need to select a target that we think we'll have success with, but it's also important that they have the level of access that we want, because in this style of environment, it's much harder to do lateral movement. So we want to target people. In this instance, we're going after the production environment or customer information there, which is likely in AWS. So we want to target someone like a developer who we think will have access to AWS and GitHub and all those kind of things, right? And then we build some kind of pretext around that. So, you've been invited to a new Slack channel, someone's shared a document with you, but they need some reason to go to and log in, right? So what does this look like? Well, here's our somewhat cool and not as handsome red team guy. He spins up a adversary in the middle server on the internet, and he's decided to phish Dinesh because we know Dinesh is a developer, and we think he'll have access to GitHub, AWS, the services that we're interested in. Dinesh then goes and logs in what he thinks is the identity provider, but it's the adversary in the middle server. We do the authentication dance with the real identity provider, and then the red team operator can take that session and log into the identity provider as Dinesh. From here, they can access the different service providers that Dinesh has access to. So we now have access to Slack as Dinesh, we have access to GitHub as Dinesh, and we have some access to AWS, to the developer environment, but not the production environment, because they have some controls in place. Cool. So we've got our initial access, but in order to progress, we need to find out a bit more about these organizations and what they look like internally and how they structure, how they're structured. So if we go back to Dunder Mifflin, we now have access to Dwight's machine. Immediately we get some information such as IP address, his username in the domain name, that kind of stuff. But we can also query the domain controller as a regular user. And from doing that, just as a regular user, you get a ton of information. So we can find all the users, we can find a lot of computers, servers, that kind of stuff. And we can also identify all the groups and their who's in what groups and what machines are in what groups, which is really helpful for trying to get to, when we want to find where we're trying to get to. So query the domain controller, and we find file server, Active Directory certificate services, an Exchange server, some other bits and pieces. The next thing we might look at is the file server, because they're storing a whole bunch of documentation related to the production environment there. And that's what we go looking for. And we find that the web application or the sales portal is hosted on another private segment that's again firewalled off from the domain. It's a Linux environment. It's accessible via a jump host. And there's a user, Michael Scott or M. Scott, who has access to this jump host. So we have a path forward. If we can get onto M. Scott's machine, we can get his SSH keys, we can get onto the jump host, we can start extracting some of that information that we're after. Looking at Pied Piper, we know that the environment is hosted in AWS, and if we kind of zoom in on AWS, we find that there's two environments here. There's a development environment and a production environment. We have access to the development environment, but not the production environment. Pied Piper makes use of containers, so ECS, for their application, and that's supported by Elastic Registry. So this is good information to have, and we kind of know where we need to get to now. So privilege escalation, lateral movement. Okay, so there's a ton of really well documented attacks for, lateral movement and privilege escalation in Windows environments. I've listed a few here. Some of them are older, some of them are newer. I'm not going to go into the details of them just now, but if you're interested, I encourage you to Google them because there's heaps of information around them. The one that we're going to use is the Active Directory Certificate Services misconfiguration. Specifically, I chose this one because it's a misconfiguration that we see a lot. It's one of the newer attacks in Windows domains, and it's very common in my experience at the moment. And essentially, by exploiting this, we can get access to a domain administrator account, and then we can access Michael Scott's machine directly. Once we're on his machine, we have access to the SSH keys, we can get on the jump host, and we can start looking at the production database and getting our goal out. Great success. So in contrast to this, Pied Piper is a little bit different. They have a few more controls in place. What we're really interested in is how does it go from Dinesh developing code to running in production? And the way that works in this instance is they have a build pipeline. Whenever he pushes new code, he can create a pull request. That pull request triggers a build pipeline. And in that pipeline, it builds an image. In the pipeline, there's some AWS credentials that are included. And then that gets pushed to ECR, and the container is spun up using this image, and test suites run, that kind of stuff. When it comes time to push this to production, Richard, the CEO, comes along. He reviews the pull request, he decides to accept it, and that kicks off another pipeline that builds an image, includes AWS credentials, and then pushes it to the production ECR instance. And then a new container will spin up, and our code's running in production. There's a bit of a misconfiguration here in that the AWS credentials, the same ones are used, and they're scoped to both the development and production ECR instances. So along comes our red team operator, and he has the same level of access as Dinesh. So he can create pull requests, and he can access the development environment, but he doesn't have access to production. He doesn't have access to GitHub secrets, and he can't merge or accept those pull requests. What he can do, though, is through a technique called a pwn request, is gain some control over the build pipeline. And he can sort of modify it to include some commands that will exfiltrate the AWS credentials to him. So, does that, kicks off the pipeline, the AWS credentials get included, and then they're exfiltrated to our red team operator. He can then use these credentials to directly log into the production ECR instance and create a poisoned image that he pushes to that instance, and then we wait. Oh, and then we wait. And over the weekend, maybe load increases, a new container needs to be spun up to deal with this load. And when that happens, the poisoned image will be used to create this new container. And we get a connect back from within the production ECS environment. And from here, we can start pulling out some of that customer data, and we've essentially achieved our objectives. So what's next? It's pretty obvious to me that there's like significant differences between these two environments, and there's definitely significant challenges for red teams in both of these environments. I don't really necessarily think one's better than the other, I just think they're different. What's pretty obvious to me though is that we're going to continue to see sort of less reliance on your on-premise Windows domains. I don't think they're ever going to go away completely, but I think there's going to be less of them, and they're going to play less of a role in environments, and there's going to be more cloud. I'm not sure if people are familiar with the Snowden leaks. There was a document called iHunt sysadmins, which sort of documented how sysadmins were what they go after because they have access to everything. I think in this new kind of cloud environment, it's much more appropriate to do iHunt developers, because where there's infrastructure as code, developers really hold all the keys to the kingdom. And then the next sort of thing I want people to take away is FIDO2 is like a great technology. It essentially kills that adversary in the middle attack path that we showed for Pied Piper. I know at Tanto, like we enforce everyone has to have a YubiKey. They have to use them. A couple of things here. If you support FIDO2 and you also support SMS as a backup or something, then you can get downgraded to the SMS multi-factor authentication, and you're back to that adversary in the middle attack. I think maybe we'll see some more browser extensions once it becomes popular, because they bypass sort of FIDO2. They're a lot harder to use. The tooling isn't as good in that space at the moment, and you have to deal with the various like Chrome app stores and that kind of stuff, which makes it a bit more difficult for red teams. And then finally, we might see some alternative forms of phishing, such as verification phishing. And that's my talk. Thank you.
Wonderful. Thank you. I've got a question for you. So in your opinion, is one harder than the other?
I don't think one's harder than the other. I think there are parts of some that are hard, like initial access in that Windows domain, I think is much harder than in the Pied Piper example, but lateral movement I feel is a lot easier in a Windows domain than in that sort of cloud-first environment. So I think it's all connected. Yeah.
Yeah, lovely. There's no questions on the app, so I do encourage people, if they want to ask a question, you can use the app. Otherwise, just stick your hand up and I'll run over. Oh, fantastic. Get my steps up today.
Yeah, it was a pretty good talk. So just wanted to ask one question in terms of lateral movement. So for you have already gained access to the system and you are moving laterally. So how do you avoid getting detected by the blue team, which they are already monitoring it? How do you keep your low profile, navigate around internal networks?
So, sorry, I think the question was around like how would you detect the...
How do you move laterally without getting detected by the security operations or defensive teams?
How would I not be detected?
Yeah.
Yeah.
Like keeping a low profile, moving laterally.
Yeah. So I think part of that is creating as little noise as possible, and that's where reconnaissance is really important for us, because if you can identify exactly the people or the targets that you're interested in, then you're not going to be spraying credentials or stuff all over the place, right? I think depending on the technique you use for lateral movement and stuff as well, there's different ways you can hide in the noise. But yeah, it is very specific, and it is a bit of a challenge.
Yeah, cool. Any other questions in the room? Got some time? So from a defender perspective now,
Yep.
what do you reckon? Because you went through EDR, NDR, and all those others.
Yep.
And in your opinion, what's the harder kind of defensive technology you've seen out there?
For me, I think EDR is probably like the best defensive technology I've seen for on workstations. Like, what I like about it is like not only does it try to stop initial infection, but it's also like constantly having a look at like what processes are doing, like which ones are reaching out to the internet, which ones are using APIs that perhaps they shouldn't, and all of that data is collected and constantly monitored. So at any time you can be like caught, right? Which is really valuable as opposed to like your old sort of AV style where they just stop signatures.
Yeah, and when you write these reports for your customers from like a red team perspective, do you have a common theme of like, you know what, this is what you need to do, and you just see it repeated over and over again?
I mean, personally, I think FIDO2 implementation is probably the thing that I'd recommend the most. Like, I can't remember a report where I haven't put that. I think the more organizations that roll it out will put them in a much better position, and I think seeing passkeys sort of really gain popularity over the last year or so has been a really positive step.
Yeah, fantastic. We have a question on the app. So, another one just popped up. Right, so within the industry of red teaming, do you only gain initial access through phishing to emails, or just depends on the scope of the assessment?
Yeah, it depends on the scope of the assessment. And I think a good red team, you should really sit down with the client and identify like what scenarios are you after. And you can run multiple scenarios, right, and go through them. But some people do physical access and drop implanted devices. I think phishing is a good one for us because I think it's a fairly realistic threat for most organizations. You also have that like insider threat, which is quite common. But yeah, they're sort of the main sort of vectors that we do.
Cool, and we've got a couple more. We've got time as well. Excellent. Right, so what's the common mistake you observe blue teams doing when responding to red team engagements?
That's a good question. I think most of the time, I think it comes down to like processes. Sometimes these processes exist, but they're not well drilled, or people maybe aren't as aware about them. And in those instances, when it starts to get confusing and people start diverging from them, there's a lot of opportunity for us to react in a way that allows us to still achieve our objectives. I think an example of this is like often there needs to be like another method of communication rather than the company communication method, so Slack or something, because if I've already compromised your Slack, I can start answering to your blue team or whatever, right, as that user, like, oh, are you hacked? No, I'm not hacked, it's fine. Not quite that simple, but like, you get my point, right?
So definitely out-of-band comms is probably a good one for everyone to have, yeah. And there's a question here just about the slides. Are the slides generally available?
Yeah, I'll make them available probably on our GitHub later next week.
Yep, fantastic. And if you could kindly go back to the attack vector slide for Windows on-prem. I think someone wants to take a photo of it.
I've got a lot of slides here, so it's one button.
You regretting those transitions now?
Yeah, a little bit. They look so nice though. Is this the one? Yep. No.
Okay, cool.
Yeah.
Alrighty, and time for one more. All right, cool. Factoring time limitation, how do you ensure you achieve your objectives within a time-boxed engagement?
Yeah, so I guess to be fair, we don't always achieve our objectives. I like to think we have a higher rate of success than failure. But the way we structure it is maybe we'll try phishing for, say, a couple of weeks. If we don't get anywhere with that, we'll move to like an assumed breach scenario where the user will give us a machine on the network and we'll move on from there. Reason being is like we don't want to waste time spending a month just doing phishing, right? Like it's not really valuable to anyone. So if we can sort of break it up in that way, then yeah.
Yeah, and if you have a look at the Corey framework, it has provisions within that as well, or
Yeah.
around that, which is good. Cool. So that's it for questions, and thanks everyone for submitting them via the app. Fantastic questions. Can we give Lloyd a massive round of applause?
Cool. Thank you.